Here's the graph of g of x. Sketch the inverse on the same grid. Is the inverse a function? And state the domain or range of the function and its inverse. So what we're going to be doing is we're going to be flipping over the line y equals x. So whenever you're asked for the inverse, your brain should also think about flipping over the line y equals x. Anytime they ask for the inverse graph, you're flipping over y equals x. The easier thing to think about, though, is any point that you have. For example, can you see that I have negative 4, 4? If I flip that point over, all that happens is my x and y values switch. 4, negative 4. And if I flip over this point, 1, 3, I'm going to get 3, 1. This red point at 3, 2 will become 2, 3. And this point, interestingly enough, at negative 1, negative 1, when you switch them, well, you get the same point. And that actually becomes something to be aware of, because you can graph one other point on here really quickly. That one right there. Does it make sense wherever your red graph crosses the diagonal line that the x and the y has to be the same? And if you switch them, nothing's going to happen. Okay? This can be important, okay, because after drawing the points, especially in this example, it might not be immediately obvious to you how you should connect them. In fact, you might go to that technique of turning your page and having a look. So, if I turn my page and had a look, does that make sense? Those ones, and then those ones. So that the red graph has been flipped over that diagonal line to become the blue graph. How do we know if a graph is a function? Do you remember? Yes, if it passes the vertical line test. So you have to get a vertical line somewhere. You can use your pencil, you can use a ruler, make a vertical line. Once you have that vertical line, you take your vertical line and you move it across. And how do you know if it, I just moved it across. Did it pass? Did it fail? Right? It failed? Can I do that with students? Pass or fail? No. And how do you know the blue one failed? Right. As soon as the graph anywhere hits more than one point, it's not a function. So the blue one, can you see with the vertical line where it is right now? It's touching the blue graph twice. Can you see that the red graph passes the vertical line test? It's only touching once, touching once, touching once, touching once, all the way through. It only touches at one point. But the blue one, oh, like, this is 3 times. Oh my goodness. Really bad. So for part B, no, it is not a function. Now, it doesn't pass the vertical line test. What does that mean? This means if there's more than one y value, right here, there's 3 y values for a given x value. This would be frustrating. Like, we use the word function for machines when they work, right? You don't want your calculator to start telling you different answers. You're like, 5 times 5, 30. What? 5 times 5, 25. Oh, that's better. I should check that again. 5 times 5, 17. You would be like, this calculator doesn't work. It's not functioning because it's giving more answers than it's supposed to. So in mathematics, we use the word function when you put an input value. When you put in an x value, you want one y value to come out every single time. That way, you can program a computer or a calculator to do things for you. When you have multiple answers having to come out every single time, that's going to cause problems for your computer, and it's going to cause problems for your calculator, and you won't know exactly what to do. So we have to find out how do we work around this. So we have these things called functions that make that work. Okay? State the domain and range of the function and its inverse. So that's part C. I'll use interval notation since we haven't done that for a while. The domain of the red graph, the smallest x value is -4. The biggest x value is +2. The range, the smallest y value is -1. The biggest y value is +4. Then on our blue graph, the domain, the smallest x value is -1. The biggest x value is +4. And the range, the smallest y value is -4. The biggest y value is 3. Oh, and I made a mistake in my domain over here, right? Biggest x value is 3. Compare the domains and ranges. What do you notice? They're the same, but they just got switched. So the key thing with inverses is that your x's and y's are going to get switched. They get switched on the graph with the points. They get switched with the domain and range. And if we go back to what we looked at just before this, okay, with this equation, the blue equation was y equals 2x plus 4. If you switch the x and the y value, so in other words, I write x equals 2y plus 4. Do you see that all I did was switch the x and the y values? And now I get the y by itself again. So in other words, I'm going to bring the 4 over to the other side. X minus 4 equals 2y. How could I get y by itself? Divide by 2. So dividing by 2 is same as a half there, right? Minus 4 divided by 2. Oh. I can switch x and y and also get the equation. And so the whole thing at the beginning where they were getting you to solve for x, it's because they're going to ask you the equation of the inverse, and you're going to have to switch the x and the y and then solve for y again, which is the same as solving for x originally. Okay, so questions after number 1 are 4 and 9.